In this lesson, let's talk about continuous uniform distributions. So one of the simplest continuous distributions in all of statistics is the continuous uniform distribution. This distribution is characterized by a density function that is flat, and thus the probability is uniform in a closed interval. So if we say A, B, so let's take a look at. So if we have A, and little b, this goes from 0 to x, and then our f of x would be 1 over b minus a, would be the f of x, or the density function of this continuous uniform random variable x on the interval AB. So we have big X, and our interval is AB. The density function of the continuous uniform random variable x on the interval AB would be f of x on the interval AB would equal 1 over b minus a for x between a and b, and then 0 everywhere else. So it has a flat density function. And the mean, so the mean would be, mu would be equal to a plus b divided by 2, and the variance would equal b minus a squared divided by 12. So our density function, and then our mean, and our variance, and then obviously the standard deviation would be the square root of that. Okay, let's look at this problem. So we have a large conference room at a certain company that can be reserved for no more than 4 hours. So both long and short conferences occur quite often. So in fact, it can be assumed that the length x of a conference has a uniform distribution on the interval 0 to 4. So we want to know what is the probability density function of, we would take 1 over b minus a, which is 4 minus 0, so it's our interval values, so b and a. That's our density function, so that would equal to 1/4. And so that's part A. And then part B says, what is the probability that any given conference lasts at least 3 hours? So we would have to do the probability that x is greater than or equal to 3 is equal to the integration from 3 to 4, because to be greater than 3 and inside this interval, it would be between 3 and 4 of 1/4, which is our density function, dx. And so when we do this integration, we end up with the probability equals 1/4. So the probability that x is greater than or equal to 3 is equal to 1/4, or 25% probability. Okay, one of the most important application areas for uniformly distributed random variables is the Monte Carlo simulation. In very broad terms, one can say that a computer simulation is the process of designing a model of real or abstract system and then conducting numerical experiments using the computer to obtain a statistical understanding of the system's behavior. So in other words, sampling experiments are performed upon the model. This requires that certain variables in the model be assigned random variables associated with certain probability distributions. This stochastic simulation of system behavior is called the Monte Carlo simulation. Monte Carlo simulations are used to construct theories for observed behavior of complicated systems, to predict future behavior of systems, and to study the effects on final results based upon input and parameter changes within a system. Monte Carlo simulations usually employ the application of random numbers which are uniformly distributed over the interval 0 to 1. These uniformly distributed random numbers are used for the generation of stochastic variables from various probability distributions. These stochastic variables can then be used to approximate the behavior of important system variables.